So here we'll see a few examples of how to find the areas or how to figure out the probabilities of certain events in the standard normal distribution. So the first question is, what is the probability that z is less than or equal to 1.75? So the first thing would be to sketch the graph and see, have some idea of what the area looks like. Now, we're looking at the standard normal distribution. Remember, the standard normal distribution has mean, which is 1, and standard deviation. Mean, which is 0, and standard deviation 1. So that would be the mean, and that would be the standard deviation sigma. So remember that the mean is in the center, and then you go 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left, and the graph is mostly done. Now let's mark the point 1.75, and we're trying to find z less than or equal to, which means it's the area to the left of 1.75. So that's 1.75. Now area to the left of 1.75 can be read off of the table B. It is a table entry, so you look at 1.7 and then go down until you hit 0.05, so that would give us the number 1.75, which is 0.9599. So that would be the area to the left of it. So the probability is equal to the area. So the probability that z is less than or equal to 1.75 is the area to the left of z equals 1.75, which can be obtained from table B, and that is equal to 0.9599. Now let's see if there's any difference between probability that z is less than or equal to 1.75 and the probability that z is less than 1.75. Now the only difference between these two is that this event includes 1.75 and this event does not include 1.75. It's just one number out of infinitely many, so it really doesn't make a difference. It is exactly the same area, except that we denote it with, or we draw it with a dotted line which says let's not include 1.75. That's the only difference, but the area remains the same. We find the area to the left of 1.75 in table B, and that's 0.9599. Now if we have to find the area between 0 and 1.75, which is equal to the probability that z lies between 0 and 1.75. That's equal to the area between z equals 0 and z equals 1.75. So the table gives us the area to the left of 1.75. Let's say this is 1.75. That's the total area to the left of it. But now we want the area only up to a certain point. So this is 0. So this is 1.75. So we only want the area between 0 and 1.75, just the blue area. So basically we find the entire area to the left of 1.75, and then we get rid of the area to the left of 0, and the total area that we get rid of is 0.5. So that's 0.9599 minus 0.5. The reason why this area is 0.5 is because the total area is 1, and half of it would be 1 over 2, which is 0.5. Now suppose we want to find the area between negative 1.75 and positive 1.75. So we have 0 in the middle. This is 1, 2, so 1.75, 1, 2, negative 1.75. And this is positive 1.75. 1.75, and we need to find the area in between. So first we find the entire area to the left of 1.75. So that's the entire area to the left of positive 1.75, and from the table that's 0.9599. So that includes everything to the left of 1.75. The next thing we do is we need to get rid of this area, which is really the area to the left of negative 1.75, and that can be obtained from the table again. The area to the left of negative 1.75 is this black area. So that would be 0.0401, and that is equal to 0.9198. So from the total area, we subtract the area to the left of negative 1.75, and that gives us the area of what we need. That's between negative 1.75 and positive 1.75. Now suppose we want to find the area to the right of, because we want to find the probability of z greater than or equal to 1.75, we find the area to the right of z equals 1.75. Remember that the table gives us the area to the left of any z value, so we know what the area to the left of 1.75 is, and that's 0.9599. So we know that from the table. So this entire area to the left of 1.75 is 0.9599. That's the area to the left of 1.75. But if we want to find the area to the right of it, then we just go 1, which is the total area, minus 0.9599, which is 0.0401. Now suppose we want to find the area between z equals negative 1.2 and z equals 1.85, because we want to find the probability that z lies between negative 1.2 and positive 1.85. So negative 1.2 is less than z is less than 1.85, just means that z lies between negative 1.2 and positive 1.85. So again, remember that the table only gives us the entire area to the left of a given z value. So I can find the entire area to the left of 1.85. So that includes everything to the left of it. But remember, I want just the area of the area that's shaded, which means from this entire area, I would have to get rid of that tiny area, which is the area to the left of negative 1.2. So if I could somehow find the area to the left of negative 1.2, then that would give me the area between negative 1.2 and 1.85. So the area to the left of negative 1.2 is 0.1151. So the total area to the left of 1.75 minus the area to the left of negative 1.2 gives us the area that we need, that is the area between negative 1.2 and 1.85.